Hello everyone. Now today's topic is the colligative properties and determination of molar mass. Now what is colligative property? Colligative property of solutions is mainly deals with the solute particle. Mainly deals with the solute particles, not in the nature of in the solid plane. See, number of solid particles. Okay, not in the nature of solid particle. And we have some colligative properties, suppose relative lowering of vapor pressure, elevation of boiling point, depression of freezing point, and osmosis. That means osmotic pressure. From these four properties, we can determine the molar mass of the solute or the given substance. Okay. So mainly colligative property is depend on the number of solid particles, not in nature. Okay. Now see first one. First colligative property is the relative lowering of vapor pressure. That means from the name we can assume that relative lowering means decreasing of vapor pressure. How it will decrease? See, when non-volatile solute dissolve in a solvent, the vapor pressure of the resultant solution becomes less or decreases. Okay, from the pure solvent, suppose we taken in a container is pure solvent, in another container some solid particle is dissolved in the solvent. Due to the external, that means which is added from the outside the solid particle, the vapor pressure decreases. Okay, because it is solids. This vapor pressure, that means this difference in vapor pressure, this difference in vapor pressure, wait, this difference in vapor pressure of the solution and the solvent, we can say relative lowering of vapor pressure. See how? Suppose lowering of vapor pressure is del P. Del means difference. P1 0 and P1. P1 0. 0 means here for pure solvent. That means vapor pressure of the pure solvent, and P1 is the vapor pressure of the solution. Okay. In this solution where solvent and solute particle is there. Here only solvent. Okay, that means pure. Here solute plus solvent. Okay, now next see, thus relative lowering of vapor pressure is defined as the ratio of lowering the vapor pressure in the pure solvent. Now see, we just know the lowering of vapor pressure. Now what is relative? Relative means to get the relative of any equation, we have to relate with the another, suppose another quantities or another properties. Okay, now see here, relative lowering of vapor pressure is means how the lowering of vapor pressure changes, or how the lowering of vapor pressure is related with the vapor pressure of the pure solvent. That's why del P by P1 0. Del P is the difference in vapor pressure, or you can say lowering of vapor pressure, and this one is the vapor pressure of the pure solvent. Okay, which is equal to P1 0. From here we got just P1 here. No, so this one number 1. Now what do you know from Raoult's law? From Raoult's law we know that P equal to P0 xi. Here 1 is given, that means for the solvent, 1 is for solvent. Okay, P1 is the vapor pressure of solvent equal to the vapor pressure of the pure solvent into the mole fraction of the solvent. That means xi1. Okay, again you know xi1 plus xi2 equal to 1. That's why if xi1 equal to 1 minus xi2, from here xi1 equal to 1 minus xi2, this one. Okay, now just put the values here, the xi1 1 minus xi2 Next, from the equation 1, we will get del P by P0, P10 equal to, in place of this one, P1, we just put the value of this one here by here. See, P10 minus into 1 minus P10 minus minus plus P10 x2 xi2, sorry, xi2. P10 cancel, remains here P10 xi2 only. In the next second step, P1 cancel in second step, not in the case in this step. Okay, second step P10 and I write directly here del P by P10 equal to xi2. That means relative lowering of vapor pressure is directly related with the mole fraction of the solute. Mole fraction of solute. Now what it means, a mole fraction of solute? Mole fraction of solute means what is the number of solute in the solution. That's why N2 is the number of moles of the solute, and N1 is the number of moles of the solvent. Now solute plus solvent equal to solution. That's why here it is N1 plus N2. It's already written here where N1 and N2 are the mole fraction of solvent and solute respectively. Now here one case is there where we just deal with the dilute solutions. Now what do you mean dilute solution? Dilute solution means is a solution where number of solute particle is very less, or inversely you can say number of solvent particle is very more, number of solute is very less and number of solvent molecule is maximum. Now see next one. If N1 is very greater than N2, that means solute particle is very less than the solvent, then N1 becomes very greater than N2, and we can write N1 plus N2 equal to N1 because here the maximum quantity is of solvent, not the solute, remember. Okay, next, if N1 plus N2 becomes N1, then from the equation 2 we can write in place of N1 plus N2 we can write N1, or what, just write the N1 del P by P10 equal to N2 by N1. Okay, here see N1 and N2 are the moles of the solute and solvent. Now what do you know about the mole? Number of moles equal to what? Number of moles equal to the molecular mass by the given weight, given mass of the solute or any particle. See, P1 by P10 by P1, this is the del P by P0 equal to W2. W2 means the amount of this one solute particle we are adding or we are given, and this one M1 is the molar mass of the solvent, M2 is the molar mass of solute, W1 is the mass, given mass of the solvent. Okay, this portion we can explain from the number of moles, okay, which I am discussed already. Next, now see, from this equation, if we know the values of P10, P1, W2, M1, W1, we can easily find out M2. As well as if we know all the quantities except any one, then we can find that any one easily by simple mathematical calculation that I am written here. See, using the above equation, the molar mass of the solute or solvent can be determined by knowing the other quantities. Very easy. Here a simple numerical is there where the vapor pressure of pure benzene at a certain temperature is 0.850 bar. A non-volatile, non-electrolyte solid weighing 0.5 gram when added to 39 gram of benzene, the vapor pressure of the solution is 845. That means decreases. C decreases. What is the molar mass of the solute substance? Here P10 is 850. That means pure, for the pure solvent. but after the addition of solute particle, it will become 845.845. That means decreases. Double 2 is 0.5 gram, 1 is 39 gram. Now see, molar mass of benzene is 78 gram per mole. If you know this, all the values, if you put the values in the above equation, that means relative lowering of vapor pressure, we will get M2 easily is 170 gram per mole. Okay, these are simple mathematical calculations you can do easily. Okay, then next colligative properties is the elevation of boiling point. See this one elevation of boiling point. Same thing here also, elevation of boiling points depend on the number of solute, not in the nature of solvent. Now see, when non-volatile solute is dissolved in a solvent or liquid, the boiling point of the resultant solution becomes higher than that of the pure solvent. Okay, that means it takes more temperature to boil. This difference in boiling point between the solution and the solvent is called the elevation of boiling point. Okay, elevation of boiling point. Now see, elevation of boiling point is directly del Tb. That means del Tb. T means here temperature. B means boil. Del T 0. This one is for solution. This one is for, you can say, pure solvent. Okay. Next, all I'm written already. Okay, where Tb is the Tb as the boiling point of the solution and solvent respectively. Okay. Experimentally is on experimental based here is derivation. Experiment, it is found that for dilute solution, remember, for dilute solutions. Now see, in previous case also we are dealing with dilute solution. Why? Because in dilute solution the number of solute particle is very less, and we did not or do not find any difficulties to describe the expressions or to just discuss the situation or discuss the chemistry behind that. That's why we are dealing with the dilute solutions. Now see, in dilute solutions, the elevation of boiling point is directly proportional to the molar concentration. Molar concentration, not the molar or normal. It is molar. That means the solution in kg, not in ml. Of the solution. That means del Tb equal proportional to M2. M2 is the molality of the solute. Remember this one. Molality of the solute. Therefore, del Tb equal to Kb. M2 Kb is the molar concentration or this molar elevation concentration. And it has the particular name also. It has Evoluscope constant. In maybe 2016 in your NCERT class 12 final exam, one short question was come. Short question came is the what is the definitions of, or the question asks the definition of this molar elevation constant. Now how? See, if M2 becomes 1, suppose see, if M2 becomes 1, then obviously del Tb becomes Kb, no? Same situation of written here. If M2 equal to 1, then del Tb equal to Kb, that is molar concentration. Elevation constant can be defined as the elevation of boiling point. That elevation of boiling point when the mole of the solute dissolve, when 1 mole of the solute dissolve in 1 kg of the solvent. That means the molality equal to 1. This is the main case. Okay. Next. Again, what do you know from the molality formula? Working formula of molality. If we put here the working formula of molality, we will get the final expression for del Tb. This one, final expression of del Tb. So if we just rearrange to get the M2, that means molar mass of solute, we will get this type of expression, where W1, M2, W2 are the what? Are the properties of the solute and solvent, which I am discussed already. Okay, in the solution, strength of solution classes. Okay. The next topic, that means this one for depression of freezing point, we will discuss in the next class. Okay, bye.